Hello students, here I am going to discuss RS configuration of the 2D molecules, nothing but Fischer projection formula. In last video I discussed the RS configuration for 3D molecules. For that we can see in description I have shared the link. So here in this case RS configuration of the 2D molecules are Fischer projection formula. So like in a 3D molecules, generally we are saying the least priority group must be below the plane. Okay, so here in this case it is a 3D representation of the molecule. For this 3D molecule, this is the exact 2D representation. Okay, so of course the molecule has that means the molecule has a 3D shape, that has a three-dimensional shape. The molecule has not a two-dimensional shape, but for our convenience we are writing in a 2D representation. Okay, nothing but a Fischer projection formula. So how to convert this 3D structure into the 2D structure? So here whatever the groups here, this hydrogen and chlorine below the plane actually, so whatever the groups which are present below the plane must be written on the vertical line in a Fischer projection formula. Of course here Fischer projection formula is nothing but that is the intersection of the, of course here chiral carbon is intersection of the vertical line and the horizontal line. So here a Fischer projection for representation involves just here horizontal line and vertical lines. Okay, so in this case in 3D molecule whatever the groups which are below the plane must be present on the vertical line. This is the main key point. Okay, whatever the groups which are below the plane must be written on the vertical line in Fischer projection formula. And here bromine, fluorine are above the plane, these groups must be written on the horizontal line. So here like in the 3D molecules that the least priority group must be below the plane, here also the least priority group must be on the vertical line, that may be top or that may be bottom. Okay, so here in this case the least priority group again in 2D representation or in Fischer projection formula that must be below the plane. Okay, in 3D representation that least priority group must be below the plane. In 2D representation that least priority group must be on the vertical line. Okay, so here in this case we can see the configuration here: first priority, here second priority, this one third priority. So 1 2 3 clockwise direction, so R configuration. Here also same, first priority, second priority, third priority. So here clockwise direction, R configuration. So next here in this case coming to this one, here first priority, here second priority, this is third priority, this one is a S configuration, anti-clockwise direction. Here first priority, here second priority, third priority, anti-clockwise direction, S configuration. Okay, so here because here least priority group is on the vertical line. In 2D representation, if least priority group is present on the vertical line, it means in its exact 3D structure that least priority group is present below the plane. So here directly we can take for clockwise direction R configuration, for anti-clockwise direction S configuration. So now here if the least priority group is not present on the vertical line, that means is not present on the below the plane. So here we can see in this case this hydrogen least priority group above the plane. So here this hydrogen present above the plane in 3D representation, now in a 2D representation that must be present on the horizontal line but not on the vertical line. So here in this case actually we should take some rotations, or we should consider some exchanges. Okay, so here in this case here by one exchange, okay, here by one exchange that hydrogen goes to the below the plane and here chlorine comes to the above the plane, so remaining these two also must be exchanged. So here in this case fluorine below the plane, here bromine above the plane. Here even number of exchanges, here one exchange, here second exchange. If you do even number of exchanges, here the configuration is not changed. Okay, that means here we can say in this case a first priority, a second priority, this third priority. So 1 2 3, that means clockwise direction, its configuration is R actually. Okay, so here in this case now here it is a 2D representation actually. Okay, it is a 2D representation. For 2D representation also we should do some operations here, exchange these two or exchange these two. Here even number of exchanges, so here hydrogen and this is chlorine, and here fluorine and this is bromine. So first priority, second priority, third priority. So 1 2 3 R configuration, because here hydrogen on the vertical line, least priority group on the vertical line, so we can take for clockwise direction R configuration. Okay, so here in this case for this 2D structure, just give the configuration as per the CIP rules. Here first priority, here second priority, this one third priority. So if you take an arrow, its configuration is yes. Okay, that's why in a 2D presentation, deciding the RS configuration, if hydrogen, the least priority group, is on the horizontal line, just we can take the reverse for what you get. That means here in this case, this arrow is in anti-clockwise direction, so we should give the S configuration. But here the least priority group on the horizontal line, so here in this case blindly we can take the reverse configuration, so its configuration is R actually. Or if you do some exchanges, we'll get the same answer with this method also. Okay, just consider, give the arrow. If the arrow is in clockwise direction, that means its configuration is R, but you have to take the reverse. But in this case here its configuration yes, so you should take the reverse, because here horizontal, this least priority group is on the horizontal line. Okay, so or we can take the even number of exchanges, or we can take the rotation also. So in this case it is an even number of exchanges. Now here I am taking the rotation of the molecule, so chlorine, here bromine actually. So here by holding this chlorine, so rotate the molecule. When you rotate this molecule, here hydrogen comes to this bromine position, bromine goes to this fluorine position, and fluorine comes to this hydrogen position. It is a rotation actually. So here carbon, chlorine, and this is a hydrogen, this is a fluorine, and this is a bromine. So here least priority group is on the vertical line, so you can take the arrow mark 1 2 3. In this case 1 2 3, this arrow mark is in a clockwise direction, so here R configuration. So here by even number of exchanges we got the R configuration, or by rotation we got the R configuration actually. Okay, so or simply we can take the reverse for for the molecule actually. If a hydrogen is on the horizontal line, directly we can take the reverse configuration. Okay, in a shortcut actually. Okay, or you can do some operations, or even number of exchanges, or rotate the molecule. So that is a method actually. Here if we least priority group is on the horizontal line, we can take the reverse directly, or we can do some exchanges or rotations. Okay, that's it. And next so here this is one more example. Here first priority, here chiral carbon first priority, and this chlorine second priority, here carbon third priority, and here hydrogen least priority group on the vertical line. So here 1 2 3, this is the its configuration is S actually, because the anti-clockwise direction. But suppose here bromine first priority, here chlorine second priority, this carbon third priority. So here 1 2 3, this arrow is in clockwise, it means R configuration, but you have to take the reverse actually, because here least priority group hydrogen on the horizontal line. Or we can do some operations for suppose here chlorine and here bromine, here hydrogen, this is a hydrogen, this is a chlorine, this is a bromine. Do some operations, that means by holding this one we can rotate the molecule. So chlorine, here bromine, and here hydrogen. So rotate about this chiral carbon. So here hydrogen comes to the vertical line, here bromine goes to place of the chlorine, and here in this case chlorine. So here we can give the configuration first priority, a second priority, third priority. So that the arrow is in the anti-clockwise direction, so its configuration is S actually. If you take the reverse, we got the S configuration, or by rotation we also got the same configuration. So here in this case, the finally for 2D molecules we should take the reverse configuration for what you get if a least priority group is on the horizontal line. Okay, so because if the least priority group is on the horizontal line, it means actually in a 3D molecule that group present above the plane. Okay, that's it. It's a very simple way, I think. for deciding the RS configuration. Okay. Next, in last class also I discussed that RS configuration of the 3D molecules. Here let us solve some more problems to identify the RS configuration for the 3D molecules as well as the 2D molecules. Okay. So in this case, the CH2OH first priority and CH2CH ethyl second priority and methyl third priority, and here hydrogen least priority. That actually a least priority group above the plane. So in this case, actually you should take that means some exchanges or rotations. Okay. So here in this case, so exchange these two actually. Okay, and here exchange these two. Okay. So that means here that CH2OH and ethyl group, and here a hydrogen below the plane, and this methyl comes to the plane. So here in this case, first priority, this is second priority, this is the third priority. So here 1 2 3 actually its configuration is S configuration. Okay, that's it. So just here we should do some exchanges, because here this least priority group must be sent to the below the plane. Okay, that's it. Now here in this case, high priority group here above the plane, here least priority group below the plane. So you no need to take the any operations like rotations or exchanges. Here oxygen first priority, next is CH2, here CH2, here CH2 CH3, here CH2Br. So here CH2Br getting a second priority, here third one. So here 1 2 3 configuration. So that means here clockwise direction, so its configuration is R actually. Okay. Or suppose here it is the structure having two chiral carbons. So in this case, the first priority oxygen, here carbon, oxygen, carbon, carbon, but here carbon is bonding with three oxygens, because here double bonded oxygen, it means here two oxygens, here one more oxygen, three oxygens. So it is getting a high second priority, this one third priority. So here taking arrow 1 2 2 3, here its configuration is S actually, that sorry, its configuration is R, because the least priority group below the plane. So here next, here coming to this one, here this case the first priority, this one second priority, and this one third priority. So here in this case, the high priority group, so of course here least priority group above the plane. So here in this case we should take some operations. So here in this case, this one third priority group, here second priority group, this one fourth priority group, and this one first priority group. So in this case, this one just here like some exchanges here, exchange these two or exchange these two. Okay. So in this case, this fourth priority group goes to the below the plane, here first priority group comes to the above the plane. Now here this one is the third priority group, and this is the second priority. Exchange these two, exchange these two, even number of exchanges totally. Okay. So in this case, so first priority, second priority, third priority, so its configuration is actually R configuration. Okay. So in this case, it's carbon chiral carbon configuration R configuration, here also R configuration. Okay, that's it. So next, here coming to this one, here that hydrogen on the plane, that is not below the plane. So here simply we can do here exchange these two, here exchange these two. So in this case, this hydrogen below the plane, this methyl on the plane. Now here this bromine on the plane, this fluorine above the plane. So here first priority, second priority, third priority, 1 2 3, its configuration is S actually. Okay, that's it. So simply like that we can do the RS configuration for any molecule. So in this case, again here first priority, here carbon, carbon is attached to the fluorine, here carbon attached to the another carbon, here carbon attached to the just here carbon. So here first priority, second priority, here third priority. So here 1 2, actually here this group is on the plane. Okay. So here in this case, we do some operations again. So for suppose in this case, actually here do like this, this one exchange these two, actually here exchange these two. That means here in this case, this one third priority, here the fourth priority, and this above the plane second priority, this one the first priority. So here 1 2 3. So in this case, for this carbon configuration is S1. Okay, that's it. So next, here for this one, the fluorine first priority, and this one second priority, this one third priority, and here fourth priority hydrogen. Okay. So actually this is on the plane, so this hydrogen must be below the plane least priority group. So here again, here we can do some operations like see this one. So this is a carbon, chiral carbon, here in this case second priority, this below the plane third priority, and this group first priority, and this one fourth priority. Okay, so here in this case I do some exchanges like in this one, yeah, this least priority group must be below the plane. So here in this case exchange these two again, exchange these two, and here exchange these two. So here in this case the first group, here this above the plane second group, and in this case on the plane third group, here this one fourth group. So here in this case 1 2 3, so its configuration is S configuration again. So like by doing some operations we can give the RS configuration simply. Okay, now if for suppose for this 2D molecules, in this case here first priority OH, here second priority, this is third priority, and total this group getting a third priority among the four groups, and here fourth priority group is on the horizontal line, so you should take the reverse configuration. It is a actually anti-clockwise, yes, but you should take the reverse configuration because this priority group is on the horizontal line. It means this least priority group is not below the plane in a 3D structure. Okay, so again here first priority, this one your second priority, third priority, so 1 2 3, the clockwise direction or configuration, but you should take the reverse configuration. Yes, of course it is a meso tartaric acid, so you should understand here for meso compound here configurations of chiral carbons exactly opposite. If two chiral carbons are there, exactly opposite configurations for those two chiral carbons. Okay, thank you for watching.